Hello, boys and girls. We've already talked about compound interest. Sorry, there's a bit of a spelling mistake there. But anyway, you'll forgive me. Compound interest. But today I just want to discuss a few further applications in terms of compound interest. It's basically using the same formula. Um, interest is equal to principal, 1 plus rate to the power of n. So basically using the same formula, just a bit of subtle differences. Okay, so a few nuances which I like to show you. Okay. Okay, so allow me to demonstrate with this example. So Aunt Eva leaves Heidi a legacy of some deposit stock that was invested for 10 years at 5.11% per annum compounded daily. The value of the check received was 21,669.68. Calculate the initial deposit, give your answer rounded to the nearest dollar, and calculate the occurrence of leap years in the 10-year. Ignore the occurrence of the leap year in the 10-year period. Okay, right. Well, that makes it a bit easier for us. Okay, but let's write down our formula. So interest is equal to principal 1 plus rate to the power of n. Okay, so there's our compound interest formula. Now, what is the nuance what we're talking about? Okay, let's see. So the rate is 5.11% per annum compounded daily. So to work out the rate, it would be 5.11 percent per annum. So it would be 5.1. Let me. Since it is a percentage, you would divide by 100. But you also need to divide by 365 because it's compounded daily. Okay, so let's calculate that rate. So we have 5.11 divided by 100, and let's divide that by 365. Okay, so we have 0.00014. So it is 0.000014. Okay, and the value of the check received was this much. Okay, so basically the interest, so they're giving you the compounded interest at the end of its 10-year term. So they're giving you the final calculated amount. Sorry, it's amount, right? So it should be amount, not interest, because the amount is actually equal to the principal plus interest. Sorry for that silly mistake. It should be amount. So the final amount is equal to 21,669.68. Now calculate the initial deposit. Okay, so this time instead of them asking you to calculate the amount, they're already giving it to you, and they want you to find the principal. Okay, so this is the subtle difference. They're not asking you to find the amount, they're asking you to find the principal. And the way we do that is we rearrange our formula. Okay, so we have principal is now equal to the amount divided by 1 plus r to the power of n. So what is n? N is the number of days, okay, in 10 years. So it should be 365 times by 10, which is 3650. Okay, so now let's continue working on our principal. So we have the amount, 21669.68 divided by 1 plus r, the rate, so it's 1.00014 to the power of 3650. Okay, and inputting that value into our calculator, let's see what we get, shall we? So let me just clear that. Now 669.68 divided by 1.00014 to the power of 3650. I'm just going to introduce another bracket just in case. Okay, and we get $13,000. Okay, so Control 1 is my shortcut key, so $13,000. So the initial principal is $13,000. So using the compound interest formula, it doesn't only allow us to calculate the final amount. We can work out the principal and the value of all these other unknowns as well, rate and the number of periods. Okay, so it's not just the final amount. We can manipulate it to manipulate the equation to determine these other values as well. So that's what I meant by subtle differences. Okay.